Hey, my sixth graders, one thing that I promised you guys that we were going to do at the end of the school year was to do the jam jar experiment that dealt with the soil. Do you remember that? I promised it to you, so here it is. I'm going to be showing it to you, and you could probably do it at home if you want to as well. All you need is some type of jar. I have a chunky salsa jar. I have a bigger one so you can see the results. You're going to need something to scoop your dirt with. You're going to need some water, and then of course you're going to have to go out and get a sample of your dirt from around your house. I went to a couple different places. I went to the front of my house, the side of my house, to the back of my yard where I have a couple trees over by a fence, and I scooped up a variety of different soil so I could get a good sampling of what I have in my own yard. So the first thing that you need to do is you need to take your dirt, and I have it marked already so I kind of know that you're going to fill the dirt in your jar about 1/3 full. So go ahead and put it in about 1/3 of the way. Now, we talked in school when we did this. Soil is made up of 3 different things. It's made up of silt, it's made up of sand, and it's made up of clay. But there's also one other thing that you're going to find inside soil, and we're going to see it right now once we start to add our water. So now you want to add the water in. Get it as closely to the top as possible. I'm going to leave a little more space because I'm going to stir it up. What do you notice? I don't know if you can see it. I can see it really good coming from the top. But what do you notice coming up? Okay. If I turn it around a little bit, you might be able to see it. Okay. Kind of looks like some bubbles. You're right. What do those bubbles represent? That represents air inside our dirt as well. So remember, different types of soils have different amounts of air in them as well. Ones that have more air are better suited for plants to grow in them. Okay, so you can see the bubbles started to stop a little bit. So the next thing I'm going to do is I'm going to take my spoon and I'm going to mix up and make a nice mud milkshake here. Kind of make sure you don't have anything stuck to the bottom. Mix it up. Okay. Make sure you don't get anything. I have some stuff stuck on my spoon. What's that stuff? Do you remember that stuff, class? That's that organic matter that you're also going to find inside your soil. Okay? All right, I'm just going to set this off to the side. Going to cap this up, and then you want this to sit for at least 1 to 2 hours. And in 1 to 2 hours, when you come back, you're going to find something amazing happen. So I'm going to take my phone, and I'm going to put the timer on, and I am going to set it for a whole 2 hours, no minutes and no seconds. And I'm starting it right now. Okay, so it's been about 2 hours, maybe a little more. The more time that you let the soil settle in the jar, the better you're going to be able to see those layers. Okay, so now I want you to think back to earlier in the school year. It was in Unit 2 and in Lesson 5 that we learned about soil. Okay. Remember, we know that soil has different properties, but the specific property we are looking at in this experiment is soil texture. Soil texture describes the relative amounts of differently sized soil particles, and those particles include sand, silt, and clay. I don't remember if you remember this little activity in class. Okay, so different soil types have different percentages of each. This specific experiment that we were doing here, or that I was doing here and you've been watching, helps to give us an understanding of what proportions these particles are in the soil where you live, specifically around my house. Okay. Now that the water has settled out, you should be able to see the different layers appearing. Sand particles are going to be the biggest and weigh the most, so they're going to be the bottom layer. Also, any pebbles will be in that bottom layer. Next up is going to be the silt layer. Silt particles are smaller than sand and weigh less, so they're going to appear over the sand. And lastly, the smallest particles are clay, and they're going to be on the top. You might see some organic material that's floating on the top. Okay, no problems. Okay. If your soil is really, really thick clay, if you shake it up, it might just be left with clay lumps on the bottom. And then next up, you're going to have the water. It's going to be discolored. Okay. That coloring is likely to be rotted plant, that organic material that is dissolved. And finally, at the top will be your floating organic material, which isn't fully rotted. That's only if you have really clay soil. But as you can see, we have 3 distinct layers in our jar. Okay. Now here comes the fun part. We're going to add some math into our science experiment. I know what you're thinking. What kind of math? Well, we have to collect some data. We need to know what percentage of each layer makes up our soil. And I bet your next question is, how do we do that? Well, what we need to do is we need to use a ruler, and we need to measure the height of the total soil and the height of each layer. Then, in order to find the percent, we're going to take the layer amount, divide it by the total height of the soil, multiply it by 100 to get the percentage. So let's give it a try. Okay, so if I take my ruler, and if you look, okay, you can definitely see where the sand particles are. Okay, if I look very carefully, there's a lighter band and then a darker band and then another lighter band in our layers. Okay, the sand here at the bottom, kind of hard to see upside down, but it's about 23 millimeters. Okay, after that, when I go up in that little darker brown band, that's about 12 millimeters. Okay, and then from there up to the top of the soil, that's another 19 millimeters, and that is going to be our clay. Okay, so sand, silt, clay. And if I total all of those together, that's about a total of 54 millimeters, 5.4 centimeters. But we're going to keep it at millimeters for our experiment. Okay. So let's do some calculations and see if we can figure out the percents of each of those. So I have a calculator to help me out here. Okay, so sand. I said sand was about 23 millimeters. So we have sand, and it was 23 millimeters. We're going to divide it by the 54, and then we're going to multiply it by 100. Okay? When I go ahead and I plug that into the calculator, okay, I get about 42.5. 42.5. So that's going to average to about 43% of sand in my sample. The next thing that I need to do is I need to calculate my silt. Okay. My silt I measured again, it was about 12 centimeters. So I'm going to take 12 centimeters, divide that by 54, and then multiply that by 100. Okay. When I go ahead and I do that, I get about 22.2, which of course is going to round to just 22%. And finally, the clay, which was at the top, okay, I measured that out at about 19 millimeters. I'm going to divide that by the total, 54, and multiply that by 100 and see what I get. I get about 35.1, which of course is 35%. Now, if I add all of these together, 43, 22, and 35, I should get a total of 100%, and I do. Okay. So, what is in soil, and why is this so important? What's the purpose of this experiment? Well, let's recap. Soil, again, is made up of sand, silt, and clay. Okay. Sand is the largest of the particles, and it's important because it allows for water to drain from the soil. But sand cannot hold on to nutrients very well. Now, our silt particles are smaller than sand, and it's helpful in holding limited nutrients and water. And then finally, we have our clay particles. They're the smallest and can hold nutrients and water the best. However, it can become heavy and waterlogged when wet. The ideal combination for good plant growth is a soil consisting of 40% sand, 40% silt, and only 20% clay. This highly desired soil combination is known as loam. So in looking at the data, how does the soil around my house fare? Is it close? If not, what might I need to do to improve its soil texture? Well, I hope you enjoyed watching this video because I truly enjoyed making it for you. And I wish we were together in the classroom working on this experiment. But, this is something you can do at home. And if you try this, post your results in Class Dojo. I'm curious to see how soils from different areas compare. It would be interesting to see your results and if they vary from mine. And as always, stay safe and stay healthy.